In this video, I'm going to show you what a one sample z-test for a proportion is. So the first thing we need to talk about is a test statistic. So if we run a test, and we always expect the null hypothesis to be true, so we run the test assuming that it's true. A test statistic measures how far a given sample diverges from what is expected, or how far away from what is expected, essentially. And so in this case, a test statistic is our statistic minus our parameter divided by the standard deviation. So we're dealing with proportion, and we're going to be dealing with z-score. So it's going to be p hat minus p sub 0, which is, so p hat's our sample proportion, p sub 0 is what we assume to be true, and our standard deviation will be calculated on that p sub 0. So it's p0 initial p times 1 minus initial p, or your null hypothesis p, divided by your sample, how many you took. So that's going to be how we calculate that. So let's start with a problem. Let's suppose DeAndre Jordan of the Los Angeles Clippers claims that he is a 60% free throw shooter. As his manager, you decide to see if there is any truth to his claim. You have him go to the line and shoot 50 free throws. He makes 23. Now, I just made this problem up. I have very little information about the NBA other than he's a real player, and his free throw percentage isn't always so great. But I'm sure he's working on it. So step one. So I'm going to give you kind of the cookbook approach. It's probably the best way to start learning this stuff. That's how I learned it, and then through time I got to understand it. So step one, state the null and alternative hypothesis. So on this proportion, our null hypothesis is, we know P, we're going to assume that he's correct, and P is 0.6. So we're going to assume no change. Our alternative is he shot quite a bit less. So our alternative is that it's going to be less than 0.6. So there's our null and alternative hypothesis. Step two, we'll define the parameter P in context and set the significance level if it's not given by the problem. Most of the time, if you're in a stats class, this is given by the problem. So in this case, P is the actual proportion of free throws made by Jordan, and we will use an alpha level of 0.05. All right, next step. So we'll do a little striptease here. Step 3, we're going to check to see if the conditions are met. So the first condition you want to check for is randomness. Is the sample random? In this case, Jordan is shooting 50 shots in a row, and this is a convenience sample and may just be catching Jordan in an off day. It would be better to randomly select 50 free throw attempts from his career, and I'll analyze those. For the purpose of this problem, we'll go ahead and note that this sample is not random, but continue anyway. So not necessarily random, but we'll keep going. We could make it random though by going back to his career and just selecting 50 of his shots, of his free throw shots. The second one is the test for independence. Is the sample independent? We sometimes call this a 10% condition. Here we check to see that the sample of 50 is less than 10% of all free throws that Jordan has shot in his career. Jordan has shot way more than 500 free throws in his career, so we have met that 10% condition, or test for independence. And then the last thing we want to check for is the large counts condition, or can we use the normal distribution, or z-score. In this case, you take 50 times p sub naught, or p0, p sub 0. So 50 times 0.6 is 30. So that's this part here. And 50 times 1, that should be 1 minus 0.6. That is incorrect. So 1 minus 0.6, which is 0.4. I threw in the answer there at the end, which is 20. Both are at least 10, so we can use the normal distribution to find a z-score and p-value. Now note, and I kind of pointed this out earlier anyways, we used your initial p for the large counts and not p hat. So we didn't use the 0.46, we used the 60% or 0.6. And the reason that is we are assuming that the null hypothesis is true. So we're going to set everything up based on our null hypothesis and test our sample against that. So step 4 is we're going to find the test statistic. So the sample proportion made free throws is 23 out of 50, or 46%. So that is p hat. That's our statistic. Okay, our standard deviation for the sample, again, I'll just throw that in with the test statistic. So to find that test statistic, or z-score, we go z equals, I gave you the formula earlier, so I'll just go ahead and plug everything in. 0.46 minus 0.6 divided by the square root of 0.6 times 0.4 divided by 50. So plug all that in and see what you get. Try and get 2.02. Make sure you're plugging it in correctly. It's negative 2.021 or whatever, but that's close enough. And so there's your test statistic. Okay, so I think we're ready to move on to the next one, which is step 5, and we're going to go ahead and find our p-value. So at this point, I just found this as a basic chart that you'd find in the back of any stats book. You can go online and find a million of them. Let's go ahead and zoom in here and I'll show you what it is. Okay, so this is that standard Z table, and kind of a nice, because we're in this left tail here, our z-score was negative 2.02, I do believe. Yeah, it's negative 2.02. And so I'm going to scroll down because I'm just about out of it. But you can find that by going negative 2 right here, and 0.02 is right there. And if you line those two up, our p-value is 0.0217. So that's the probability of getting below, of getting a sample less than what we had, less than or equal to 0.0217. So there's our p-value. We'll use that in a second. The other thing we could do is you could calculate this thing in Geogebra, which works really well. So we'll go ahead and so I went to geogebra.org, O-R-G, and you go to get started, go down to probability, and here it is. And I'll see if I can't, there we go. For the most part, I can fit it in there pretty good. And so we go to statistics, and this is a z-test of a proportion. So we'll click that. And what's cool is this, you just plug it in. Null hypothesis is 0.6. This is a less than. And we had 23 successes in our sample out of 50. And what you'll notice is at the bottom here, it matches it up, 0.0217 with a z-score of negative 2.021. And there you have it. So let me pull that out, and I think I can go down so you can see that on the top of the screen better. Nope, that's as low as high as I can get it. There, I pulled it up a little higher, but you can see the summary of that z-test of a proportion in GeoGebra. And you can see the 0.0217, exactly what we got off of the table, which is pretty cool. At least I think it's pretty cool anyway. Okay, so the other place you could do this is in your TI calculator. So in a TI calculator, I have a kind of large blown up picture. I'm working on getting an emulator. I just don't have it set up yet. But you hit menu once you get into the calculator. Use the arrow down key to get to statistics. Then you'd go over here to stat test. So you'd arrow over, go down to stat test, arrow over. Then you would go ahead and do a 1 prop z-test and enter in your data values. So 0.6 for piece of knot, 23 for successes, 50 for the number in our sample. Switch this to a less than for our alternate hypothesis. Hit OK, and beautifully it will pop up as everything you need. So it's negative 2.021 z-score, which we found. P-value 0.02165 gives you a little more there, and a p-hat of 0.46 and out of a sample of 50. So that's kind of nice. So you can get these pretty quickly with your So the last step is just your conclusion. So because the p-value of 0.0217 is less than an alpha level of 0.05, which we set before we conducted the test, we reject the null hypothesis, and this suggests that there is convincing evidence to support the conclusion that Jordan's free throw percentage is indeed lower than 60%. So I hope this helps you understand a one proportion z-test, and see you next time.